we'll practice analyzing the motion and forces in a system of two masses connected by a cord over a pulley, one on an incline and one hanging. Here's the problem. A 4.0 kilogram block rests on a frictionless 25-degree incline and is connected by a cord over a pulley at the top to a 3.0 kilogram mass hanging vertically. Determine the acceleration of the system and the tension in the cord. First, we take the hanging mass falling as positive. The net force on the system is the weight of the hanging mass minus the component of the incline block's weight along the incline. Net force equals m2g minus m1g sine theta. Plugging in the numbers, 3.0 times 9.8 minus 4.0 times 9.8 times sine 25 degrees. This gives 29.4 minus 39.2 times 0.423, which is 29.4 minus 16.6 equals 12.8 newtons. Now find the acceleration using Newton's second law for the whole system. Acceleration equals net force divided by total mass, 12.8 divided by 7.0, which is 1.83 meters per second squared. Next, find the tension. Consider the hanging mass, m2g minus t equals m2a. So t equals m2 times g minus a, which is 3.0 times 9.8 minus 1.83 equals 3.0 times 7.97 equals 23.9 newtons. Check using the incline mass. T equals m1g sine theta plus m1a. It gives 16.6 plus 4.0 times 1.83 equals 23.9 newtons, which matches. So the acceleration is 1.8 meters per second squared, and the tension is 24 newtons. Remember to treat the system as a whole for acceleration, then isolate a single mass to find the tension.